Introduction. Physical access is security. If a switch is exposed, your network is exposed. Key trends and system-level innovations. Zero trust. Physical access. Physical access treated like network access. Continuous, identity-verified, role-based, two-factor and biometric at the rack. RFID plus PIN or biometrics for high-assurance environments. AI-driven access control. AI analyzes access patterns for anomalies. Early cloud AI, vision-assisted prototypes are emerging. Multi-layer physical security. Door, room, cage, rack to mitigate insider threats. Integration with DCIM and power tools. Locks tie into DCIM and monitoring, for example, the Eaton vCom VPM, to link access with operations. Remote and API-driven access. PoE-powered networked locks with directory integration, LDAP-AD, REST APIs, HTTPS, and SNMP. Representative product examples, not endorsements. HES, KS200, wired Wigand OSDP cabinet lock for direct enterprise integration. The KS210 utilizes Open Supervised Device Protocol, OSDP, to achieve end-to-end encryption for high-security applications, daisy-chainable, secure two-way communication. Dormakaba ePlex 5792. RFID plus keypad offers two-factor without mechanical keys. Chatsworth eConnect RFID kit adds RFID access to standard cabinets. Rutherford 3525PRX. Prox-enabled retrofit swing handle Xi-Fi I-Class E-Lock is a wireless, electromechanical server rack handle with an integrated 125 kHz proximity. Prox card reader, designed for access control in data centers, industrial cabinets, and secure storage. It offers electronic locking, remote monitoring via Wigand output, local LED status, and mechanical key override, allowing secure, controlled access with RFID credentials to secure server racks and cabinets. Dashboard managed, card plus keypad, Grid Connect RFID swing handle, rugged industrial RFID lock. Other notable systems. Eaton Tanlock, modular multi-auth rack security platform. Vanma passive locks, power-free, encrypted, auditable. Why these technologies matter. Audit and compliance. Cabinet-level identity logs and tamper evidence support certifications and investigations. Insider risk reduction, limit who can touch specific hardware. Scalability and flexibility. Modular authentication adapts as needs evolve. Defense in depth. Rack-level controls complement room and perimeter security. Smart enclosures and secure drawers. Locked, compartmentalized subracks segregate HSMs and KMS. HSMS can refer to hardware security modules, HSMs, physical devices securing keys for encryption, digital signatures, and IT finance, or high-speed SECS message services. Key management system, a crucial platform for securely creating, storing, distributing, controlling, and destroying cryptographic keys, which are essential for encrypting and decrypting sensitive data, ensuring confidentiality and compliance with regulations like HIPAA and GDPR. KMS provides control over the entire key lifecycle, protecting data from unauthorized access and integrating with cloud services to manage data security effectively. Key risks and trade-offs. High cost. Electronic and modular systems are expensive at scale. Deploying a robust physical access control system, PACS, requires proactive mitigation of 4 core risks. The design complexity inherent in lifecycle management and system integration, dependencies on enabling infrastructure like PoE networks, the availability risk of single points of access, and the catastrophic systemic threat posed by a breach of the centralized management software. Each demands specific controls, meticulous design documentation, validated infrastructure prerequisites, redundant entry modalities, and zero trust segmentation of the management layer to ensure the system's integrity and availability. Summary: secure enclosures, controlled access, logged changes, and field-verified practices. Questions? Photos, maps, and logs are ready. The primary challenge lies in architecting a secure, reliable, and manageable physical access system that accounts for credential lifecycle complexity and infrastructure overhead. Core to this architecture is ensuring fault-tolerant availability through redundant access methods and categorically defending the centralized management software as the system's highest risk component. The security model should culminate in applying zero-trust principles at the physical enforcement layer, creating identity-based micro-perimeters at critical assets to enforce least privilege access and contain potential threats. Example: AI-driven access, anomaly detection from access patterns and cameras. Example: modular authentication swap RFID, PIN, biometric or QR modules. Example: passive locks, encrypted keys, no wiring, full audit trail. Example: multi-layer security, door, room, cage, then rack. Example: DCIM integration locks linked to monitoring and power events. Example: two-factor at the rack, RFID plus PIN or biometrics. Example: remote API-driven access, LDAP AD, REST, HTTPS, SNMP. Example: tamper evidence with cabinet-level identity logs and SIEM integration. Example: smart enclosures secure drawers segregating HSMs and KMS. Shown are several locking containers we are using now. These just slow the perpetrators down. Examples: HES KS200 and KS210, Wiegand OSDP cabinet locks. Examples: Dormakaba ePlex 5790 and CompX Advanced eLock, keypad plus RFID. Examples: Rutherford 3525 PRX and GridConnect, RFID swing handle retrofits. Examples: Chatsworth eConnect RFID kit and CompX Wi-Fi iClass eLock. Example: Eaton Tanlock, modular multi-authentication rack security platform. Example: Vanma passive locks, power-free encrypted keys with audit. There are many examples, but to achieve operational resilience, we must architect the system to manage credential lifecycles and infrastructure dependencies while implementing redundant access pathways and hardening the centralized management plane under a zero-trust framework. The security model must then extend these zero-trust principles to create identity-verified micro-perimeters at critical physical assets. Finally, continuous governance through scheduled audits, policy reviews, and a dedicated incident response plan is required to maintain system integrity and adapt to evolving threats, one by one.